Right, so this demo is going to demonstrate governance of KYC checks, so knowing age and residency, and then issuing tokens for people to hold. So basically a stablecoin GBP token that is only able to be issued by people who are UK residents and are over 18. In this first bit, I've got 4 different accounts. So I've opened 4 instances of Kerry. I used one I've got running locally. The other ones are in the GitHub repo. Just so all of their identities, the local storage, this is all stored in the browser, is completely separate. So I've got some private browser instances and everything else, just to kind of drive home the point that all of this data on here, there's no server backend. Everything I'm doing in this setup, and that you would do if you went to these pages, is completely stored in your browser, and you can check the network traffic and everything else and know that all of your data is safe there. So this is just bootstrapping these accounts, so creating new users with just some sort of alias. You can see these passkeys, these mnemonics that we're using for the initial private key is shared in this public video, but that's all right because the way Kerry handles key rotation, it's built and designed for people to have to rotate their private keys. So in case they accidentally are compromised or leak that their key, their passphrase, they can just come into their profile and choose to rotate keys and have a new private key. Here I just say don't prompt me again, so I can just keep on mashing that button, but you can see my public key and the next digest change when I rotate those keys. So the next thing to do is to define a schema. So as I go into my DVLA persona, I come and define a schema or form basically. So I'm going to call this driver's license, and these are going to be the fields that I attest for driver's license holders. So personally identifiable information such as your name, first name, last name, and your date of birth, which is a date, and then I create the schema. I'm also going to create a second schema that will allow the DVLA, so an official recognized government body, to issue credentials that simply say that somebody is over 18 or over 21. So people can recognize that the DVLA has issued these credentials and issued these claims, and the holders of these claims don't have to reveal sensitive information. So now with the schema, the next thing to do is to set up a credential registry. So this is essentially a directory or folder structure where we're going to anchor and link the credentials that we issue to our DVLA account. So now it's time to give Alice a driver's license. So we're going to do that by sharing the identity of the holder with the DVLA. So as I share my profile in Alice's account, I can come and add a contact in the DVLA accounts. So I'm going to put an alias. I'd probably have Alice's full name there, but that's the Kerry credential that I've just imported, and now the DVLA knows about Alice. So Alice has a globally unique aid, so a UUID or unique identifier that's going to basically mean this is Alice. So here I can choose Alice now from my holder of the certificate, and I can choose the schema that I created, which is a driver's license, and I can fill in the information that I know about Alice, such as her first name and her date of birth, and I'm going to issue that credential. I'm also going to issue a credential for Alice that allows her to say that I know what her age is as a DVLA representative, but she doesn't have to tell people her date of birth or even her name. So I'm going to choose the proof of age schema and just say, yes, I know that Alice is over 18 and she's over 21, and I can issue that for Alice. I'm also going to link then from that certificate to the full FAT, this is all of our private data certificate. So those two have a connection, an edge connection in Kerry terms. At that point, I can share it. So I've shared now that certificate, and I come into Alice's identity, and I create a registry for her to hold her attestations and her credentials. And I'm going to take that Caesar representation of that credential, and I'm going to import it into her registry. Alice can call it whatever she wants, and she can put it wherever she wants. So she's just going to say, okay, this is my driver's license, and she can see that it's valid, and she now holds that certificate. as we also share the private credential, which only attests to Alice's being over 18 and over 21, I just wanted to point out that all of this in this demo is happening via the clipboard. In real life, you would be sending this out of band. You'd be sending it in an email as an attachment, or however you want to communicate that. Or equally, we can set up some messaging services or whatever else to give the user a better user experience. So she has her proof of age certificate, and she's put in one credential registry. She has her more private driver's license with her full date of birth and name and everything else someplace else. And I'm just going to speed through this next bit because it's the same, but this is the equivalent for HMRC. So HMRC creates their own registry. They issue some credentials for Alice. They share it. They send it over to Alice. And she can go ahead and choose that she wants to put HMRC's proof of residency in the same place that she put her driver's license. So she's going to import that here as well. All right, finally, the issuer flow. This is probably the more interesting bit. So finally, Alice wants to go and she has her attestations from the DVLA and the UK government, HMRC, saying, you know, yes, I'm a UK resident, and yes, I'm over 18. So she's going to be careful to choose the public credentials and share that, yes, I'm over 18. And here the issuer can say, okay, great. The DVLA has issued that for you, and I can check that, yep, you are over 18. And I'm also going to import your residency attestation. So we have that claim and that credential. Now the token issuer has designed their own schema when onboarding users that provides that link between their account or their wallet address and those KYC credentials that they require. So essentially Alice is saying, here's the proof of all the things you need, and also here's my account number or my wallet address, and the issuer wants to link those two things together. So when they come to onboard Alice, they're going to say, okay, great, you need to show me what account do you want me to issue these tokens to. And to fill that in, we're going to pop over to essentially what it would be Alice going in to grab her wallet address, the equivalent of her TradFi sort code and account number. I'm just going to grab a test account in my hard hat network, but basically saying, yep, this is my account. And as the issuer puts that in, they're now linking on the third step of the credential issuance, the KYC steps, the KYC credentials that say, yes, we've checked that Alice is over 18 and over 21, and yes, we've checked she's a UK resident. This makes sure that we have a verifiable record that all of those pieces of information are linked. And finally, to pivot to verification or validation, if we look at any of these credentials, we can click on these links and it'll show us the Graph Explorer, the sort of bottom menu item. And this has a lineage and a linkage of everything that we've done, from our account creation to key rotation to credential registries, credential issuance and acceptance. And if we select a node or hover over it, there's a little panel on the right that contains the event, data itself, the public keys that sign that account, and the signature of those two pieces of information. So here you can see me sort of just playing around and manually editing any of those pieces of information just to prove and visually see that it does work. So when I click verify, I can see, oh yeah, the ID is valid, but the signature isn't if I change the public key or the private key, the signature. And I reset that to what it was, the actual event in that chain, and it's all valid. And that works for any of the nodes in the history that I could just click on and explore. And just as another visual, there's a little naughty kind of Git-looking graph to see the history of everything. Okay, so moving back over to the issuer flow now, I just want to call out in this onboarding, this is probably technically two different roles or two different departments from the token issuance, but I kept it simple in this case just to keep the demo short. But essentially, we're taking Alice's wallet address, and we have one token or one contract that's just responsible for that due diligence and that onboarding. So here we're going to deploy a governance contract and put Alice on the allow list that binds her wallet address and a reference to the carry node where we did that onboarding. So we have the one piece of information that binds her wallet address and the fact that she's over 18 or over 21 and a UK resident. So finally, Alice gets to hold her GBP token, so her GBP adult token. So any holder of this, we know that they have to be over 18 and a UK resident. So I'm going to go and deploy this token, confirming the transaction in MetaMask. And now I'm going to go ahead and give Alice some tokens, some digital currency, a stable coin. So she's probably given me some cash or whatever she's done. She's wired me some payment of some actual GBP money, 123 pounds. So I'm going to go and say, okay, great, I'll deposit the equivalent into your account. And I approve that transaction. And it's minted. And I can see that she holds 123 pounds now in digital currency. And I'm just going to grab another random account now to kind of prove the opposite. So if I just grab another address, and this person tried to give me some money, and they want me to mint them some tokens, and I try to say, okay, here's 200 pounds, I can see it fails. So that's it. That's how the sausage is made. What's most interesting is what happens next, in that anybody holding a GBP stablecoin or GBPA stablecoin knows that the due diligence has been done to say they're a UK resident and that they're an adult.